This is a video walkthrough for practice 10.1 on arithmetic and geometric sequences. In 1 through 2, we're asked to use the given sequence to find a sub n, and in number 1, we are finding a sub 2, which is the second term, so a sub 2 is equal to 7. In number 2, a sub 4 means the fourth term, so a sub 4 equals 11. In 3 through 4, we're again using the given sequence to complete each statement. This time, the statement is if a sub n equals 16, and look at 16's placement in the sequence, then n is equal to 4, because n is 4, that means the number of the term. In 4, if a sub n is equal to x cubed, again look at x cubed's placement in the sequence, then n is equal to 1 because a sub n equals x cubed is the first term of the sequence. In 5 through 14, we're determining if each sequence is arithmetic, geometric, or neither. And if so, find the common difference or common ratio. In number 5, a tip when looking at these types of sequences, if the sequence alternates between negative and positive numbers, then we can have a sequence in which we are multiplying to get from term to term by a negative number. So let's look at the ratios of terms. So a sub 2 divided by a sub 1 is negative 2 divided by 3. A sub 3 divided by a sub 2, each term divided by its previous term, is 4/3 divided by negative 2, and that's also negative 2/3. If we divide any pair of terms, that term divided by its previous term, the ratio will be negative 2/3, and so therefore this is a geometric sequence with a ratio, or a common ratio, of negative 2/3. In 6, there is a common difference. A sub 2 minus a sub 1 is 12 minus 4, which is 8. A sub 3 minus a sub 2 is negative 4 minus 4. That is, negative 4 minus negative 4. Let's start again. A sub 2 minus a sub 1 is 4 minus 12, which is negative 8. A sub 3 minus a sub 2 is negative 4 minus 4, which is also negative 8. And if you subtract any pair of terms, the term minus the term before it, you get negative 8. So this is an arithmetic sequence with a common difference of negative 8. In number 7, if I look at common differences, a sub 2 minus a sub 1 is a half minus 1 is negative a half, and a sub 3 minus a sub 2 is a third minus a half, which is equal to 1/6. So we do not have a common difference. Let's look at ratios. A sub 2 divided by a sub 1 is a half divided by 1, which is a half. A sub 3 divided by a sub 2 is 1/3 divided by 1/2, which is 2/3. So we do not have a common ratio, nor do we have a common difference. So therefore, this sequence of numbers is neither arithmetic nor geometric. In number 8, it may be more obvious if we give each of these numbers here a common denominator. So 4 is equivalent to 8 halves, 3 halves, and negative 1 is equivalent to negative 2 halves, and then negative 7 halves is our next term. At this point, it may become more obvious that there is a common difference. A sub 2 minus a sub 1 is 3 halves minus 8 halves, which is negative 5 halves, and a sub 3 minus a sub 2 is negative 2 halves minus 3 halves, which is also negative 5 halves, and we can do this for any pair of terms. And so this is an arithmetic sequence with a common difference of negative 5 halves. In number 9, if we look at differences, a sub 2 minus a sub 1 is 7 minus 5, which is 2. A sub 3 minus a sub 2 is 10 minus 7, which is 3. A sub 4 minus a sub 3 is 16 minus 10, which is 6. And a sub 5 minus a sub 4 is 27 minus 16, which is 11. There is a pattern here. However, it's definitely not an arithmetic pattern. So let's take a look at ratios. A sub 2 divided by a sub 1 is 7 divided by 5. A sub 3 divided by a sub 2 is 10 divided by 7. Stop. The two ratios are not equal, so this is neither arithmetic nor geometric. In number 10, 2.2.02.002, this is a geometric sequence, and here's how I know that. A sub 2 divided by a sub 1 is 0.2 divided by 2, which is 0.1. A sub 3 divided by a sub 2 is 0.02 divided by 0.2, which is also 0.1. And a sub 4 divided by a sub 3 is 0.002 divided by 0.02, which is also 0.1. So this is a geometric sequence with an R value of 0.1. Number 11 has terms with exponents that follow an arithmetic progression, that is adding 3. However, this is a geometric sequence because a sub 2 divided by a sub 1 is x to the 4th divided by x, which is x cubed. A sub 3 divided by a sub 2 is x to the 7th divided by x to the 4th, which is also x cubed, and we can do this for any pair of subsequent terms. So this is a geometric sequence with an R value of x cubed. In number 12, we have some logarithms. Now, if you look at the arguments of the logarithms form a geometric progression. 3 times 3 is 9, times 3 is 27, times 3 is 81, etc. However, the logs themselves are referring to the exponents. And so what we can say is that, for instance, log base 2 of 9 minus log base 2 of 3, that's our difference between the second and the third terms, is log base 2 of 9 divided by 3, which is log base 2 of 3. If I take the third term and subtract the second term, then that's log base 2 of 27 divided by 9, which is log base 2 of 3. So we actually do have a common difference of log base 2 of 3, and so this forms an arithmetic progression with a common difference of log base 2 of 3. In 13, we can look at differences. A sub 2 minus a sub 1, which would be 5/7 minus 3/5, and that is going to be a common difference of 4/35. A sub 3 minus a sub 2 is 7/9 minus 5/7, and that will be 4/63. Right away we know we do not have a common difference. So now let's check ratios. A sub 2 divided by a sub 1 is 5/7 divided by 3/5, and this is 25/21. And a sub 3 divided by a sub 2 is 7/9 divided by 5/7, and that will be equal to 49 over 45. We do not have a common ratio, so this sequence is neither. It might be interesting to note that if we just look at the numerators of each of these fractions, the numerators form an arithmetic progression, as do the denominators, but the fractions do not form an arithmetic progression. All right, in 14, in this time it looks like we have a geometric progression, and I can kind of see that because my numbers are getting bigger by a factor, right? You can develop a sense for this. Let's look at ratios. A sub 2 divided by a sub 1 is 2/9 divided by 2/81, and that is a ratio of 9. A sub 3 divided by a sub 2 is 2 divided by 2/9, and that is also a ratio of 9, etc. So multiply by 9 is the pattern. This is a geometric progression, with an R value of 9. In 15 through 23, we are assuming that each sequence is arithmetic with an nth term a sub n and a common difference d. So in 15, we're asked to find the 25th term in the sequence, and we're given the first term and the common difference. Our formula here is a sub n, the nth term is equal to the first term plus the common difference times n minus 1. The 25th term implies that n is 25, so I'm going to replace all my n's with 25. And a sub 25 is the 25th term. That's the one that we're looking for. A sub 1 is the first term. We have that. D is given to us. And 25 minus 1 is 24. And so now we just need to multiply 3 times 24 and add 8. That's 72 plus 8 is 80. So the 25th term is 80. In 16, for this arithmetic progression, a sub n is equal to a sub 1 plus d times n minus 1. That's the formula for the nth term of an arithmetic sequence. This time we're given a sub n, and we're given a sub 1, and we're also given the difference, and we are looking for n. So negative 41 is equal to actually, you know what? We can subtract 19. That will make this a little cleaner. So subtract 19 first, and we get negative 60 is equal to negative 5 times n minus 1. Dividing by negative 5, that gives us n minus 1 is 12. And solving for n is 13. In 17, we're going to use our formula for nth term. A sub n is equal to a sub 1 plus d times n minus 1. And we have information about the 15th term. So I'm going to replace my n with 15. And a sub 15 is 38. And we don't know the first term, but we do know that d is negative 3, and 15 minus 1 is 14. So 38 is equal to a sub 1 minus 3 times 14, which is minus 42. Add 42 to both sides, and we should get 80 for the first term of this sequence. In 18, we have an arithmetic sequence, so a sub n is equal to a sub 1 plus d times n minus 1, and we are given information about the 14th term, so I am going to replace my n's with 14. A sub 14 is equal to 58, a sub 1 is equal to 6. We don't know what d is, but we do know that 14 minus 1 is 13. So now subtracting 6 from both sides, 52 is equal to 13 times d, and dividing by 13, d is equal to 4. In number 19, we have an arithmetic sequence, and so a sub n is equal to a sub 1 plus d times n minus 1. And we are asked to find the 79th term, so we are replacing n with 79. And so a sub 79 is equal to the first term, which is negative 7, plus d, and d is positive 3, since negative 7 plus 3 is negative 4, and 79 minus 1 is 78. So a sub 79, or the 79th term, is equal to 3 times 78 plus negative 7. Which is 227. So the 79th term is 227. In number 20, we have an arithmetic sequence, and we are looking for the first term, and we have the common difference in the 7th term of the sequence. So we're going to use our formula a sub n is equal to a sub 1 plus d times n minus 1. And since we're given a sub 7, that implies that n must be equal to 7. So I'm going to replace all my n's with 7. A sub 7 is the 7th term, and that's equal to 3. A sub 1 is not known. D is negative 2, and 7 minus 1 is 6. So 3 is equal to a sub 1 minus 12, which means that a sub 1, the first term, must be equal to 15. In 21, we're finding the common difference for the sequence where the first term is 100 and the 12th term is 34. So I'm going to use my formula for the nth term of an arithmetic sequence. A sub n is equal to a sub 1 plus d times n minus 1. Since we're given a sub 12, that implies that n must be equal to 12. So I'm going to replace all my n's with 12. A sub 12 is the 12th term, and that's equal to 34. A sub 1 is the first term, and that's 100. And we don't know the common difference, but we do know that 12 minus 1 is 11. So 34 is equal to 100 plus d times 11. Subtracting 100, that gives us negative 66 is equal to 11 times d. So d is equal to negative 6. In number 22, we have an arithmetic sequence in which the first term is 5, and a common difference is 3, and we want to know which term has a value of 101. So I'm going to use my formula for the nth term of an arithmetic sequence. A sub n is equal to a sub 1 plus d times n minus 1. This time we know the value of the term, so a sub n is 101. We just don't know what number term it is, and so that we are looking for the value of m. The first term is 5, the common difference is 3, and so now I just have an algebraic equation to solve. Subtracting 5, that gives us 96 is equal to 3 times n minus 1. Dividing by 3, 32 is equal to n minus 1. So that means that n is 33, so the 33rd term has a value of 101. In number 23, we are looking for the number of terms in this sequence, and so we're missing some terms here in the middle. We do know the first 3 terms, however, and this is an arithmetic sequence we were told, so a sub n is equal to a sub 1 plus d times n minus 1. We do know that a sub n is 134. We just don't know what number term it is, which will tell us how many terms there are in the sequence. So we're going to be looking for n. A sub 1 is 2, and we can see that 2 plus 3 is 5, 5 plus 3 is 8, so our common difference is 3. Given that this is an arithmetic sequence. Subtracting 2 from both sides, 132 is equal to 3 times n minus 1. And so, dividing by 3, 44 is equal to n minus 1, so n is equal to 45. So that last term is the 45th term, which means there are 45 terms in the sequence. In 24 through 32, we're shifting gears. We are assuming that each of these sequences is geometric with an nth term a sub n and a common ratio of r. So we are finding the 6th term in the sequence where the first term is a half and the common ratio is negative 4. And so I'm going to use my formula for the nth term of a geometric sequence. A sub n is equal to the first term a sub 1 times r raised to the n minus 1 power. So we are looking for the 6th term, which implies that n must have to be equal to 6. So I'm going to take a moment and just replace all of my n's with 6. A sub 6 is the term that we are looking for. A sub 1 is the first term, that's a half, and our common ratio is negative 1/4, and that's being raised to the 6 minus 1, which is the 5th power. Now we can take a moment and let the calculator do the computation, which gives us that the 6th term is negative 1 divided by 2048, or 2048. In 25, we are finding n for a sequence with the nth term given of 3 divided by 8,192, and the first term is 384, and the common ratio is 1/2. So I'm going to use my formula for the nth term of a geometric sequence. A sub n is equal to a sub 1 times r raised to the n minus 1. A sub n is given to us, that's 8,190 seconds, and a sub 1 is also given to us, that's 384, and r is also given to us, that's 1/2. Since we are solving for an exponent, we are going to need logs, so I'm going to divide by 384 first. If it makes it easier to do the computation, you can think of this as multiplying by 1/384 instead of dividing by 384. So we get a result of 1,048,576, and that's equal to 1/2 raised to the n minus 1 power. Solving for the exponent, n minus 1 is equal to the log base 1/2 of 1 over 104,856, and so n is equal to 1 plus the log base 1/2 of 1 over that really big number. And when you are doing this on your calculator, if you wish, you can enter that exact form answer. When we do this on the calculator, feel free to use the answer feature. So 1 plus, and then the log base 1/2, I'm going to type that in, but then I'm just going to cursor over inside the argument of the logarithm and just use the answer feature rather than retype that fraction. So that's control negative, and that's going to give me 21. So n is equal to 21 for this sequence. In 26, we are looking for the first term, and we're given the 11th term and the common ratio. So for any geometric sequence, the nth term is equal to the first term times the common ratio raised to the n minus 1. Since we're talking about the 11th term, I'm going to replace all of my n's with 11. So now a sub 11, the 11th term, is 96. A sub 1, the first term, is not known. R is 1/2, and 11 minus 1 is 10. So if we want to do this computationally and let the calculator do some of the computations, we can just enter 96 divided by 1/2 raised to the 10th power. So on your calculator, 96 divided by, parentheses here for your fraction, 1/2, and then go outside the parentheses, raised to the 10th power, and that's 98,304. In 27, we are finding R for a sequence with a first term 6 and a 7th term 93,750. So I'm going to use my formula for the nth term of a geometric sequence. A sub n is equal to a sub 1 times R raised to the n minus 1. And so since we're talking about the 7th term, I'm going to replace all of my n's with 7. A sub 7 is 93,750, and a sub 1 is 6. R is not known, and 7 minus 1 is 6. So dividing both sides by 6, we get 15,625 is equal to R to the 6th, and then we can take a 6th root. So R is equal to the 6th root of 15,625, which equals 5. If you're looking for a way to do this on your calculator, you can raise 15,625 to the 1/6 power rather than taking a 6th root. There is a way to find that, but I find the fractional exponent easier. In 28, we're finding the 10th term in the geometric sequence given with the first three terms 1/4, 3/2, and 9. So it might be to our benefit to try to figure out what R is first. So R is the ratio of one term divided by its previous term. 3/2 divided by 1/4 is 12 divided by 2, which is 6. And we can verify that with the third term divided by the second term. 9 divided by 3/2 is 18/3, which is also 6, right? So we do have a common ratio. I'm going to find the 10th term, so I'm going to use my formula for the nth term of a geometric sequence. A sub n is equal to a sub 1 times R to the n minus 1. Since we are looking for the 10th term, that implies that we must replace n's with 10. So a sub 10 is equal to a sub 1 times R to the 10 minus 1. And the 10th term is what we are looking for. A sub 1 is the first term, that's 1/4. R is 6, and 10 minus 1 is 9. So now we just have a computation to do. 1/4 times 6 raised to the 9th power is 2,519,424. In 29, we are looking for the first term in a sequence with R equal to 4 and a sub 7 equal to 400. And of course, we were given that this is a geometric sequence, so a sub n, the nth term, is equal to a sub 1, the first term, times R raised to the n minus 1 power. Since we're talking about a sub 7, I'm going to replace all my n's with 7. So a sub 7 is equal to a sub 1 times R to the 7 minus 1. A sub 7, or the 7th term, is 400. We don't know what the first term is, but we do know that R is 4 and 7 minus 1 is 6. So if we want to solve for R, a sub 1, or the first term, is equal to 400 divided by 4 raised to the 6th power. Feel free to put that into your calculator all at once. And we get 25/256. In 30, we're looking for the common ratio for a geometric sequence with the first term 12 and the seventh term 316, or sorry, 3/16. So my nth term formula is a sub n, the nth term is equal to a sub 1, the first term, times r raised to the n minus 1. Since we are talking about the seventh term, I'm going to replace all of my n's with 7. So a sub 7 is 3/16, a sub 1 is 12, and r is unknown, but 7 minus 1 is 6. So we need to now divide both sides by 12, and if you want to, you can think of this as multiplying by 1/12. And that gives us the result, 1/64. And now, in order to find r is equal to the sixth root of 1/64, which you can find by raising 1/64 to the 1/6 power, and that gives us a 1/2 for the common ratio. In 31, the first term in a sequence is 5, and the common ratio is 3, which term has a value of 295,245. So I'm going to use my formula for the nth term of a geometric sequence. And the nth term this time is 295,245, and the first term is 5, and the common ratio is 3. We are just looking for the number of that term, or we're looking for n. So I'm going to start by dividing by 5, which gives us 59,049 equals 3 to the n minus 1. If we're solving for the exponent, we need a logarithm, so n minus 1 is equal to the log base 3 of 59,049, and n is equal to 1 plus the log base 3 of 59,049. Now we have a calculator-ready answer, so we can put that in the calculator, 1 plus log base 3, and then just use the answer feature so that you do not have to type that number again. And that'll give us 11. So there are 11 terms in that sequence, or that is the 11th term. In 32, we are looking for how many terms there are in the sequence. We know that 1 is the first term, a half is the second term, etc. So we are just basically looking for what number term is 1 divided by 4,096. So we're looking for n. So a sub n for a geometric sequence is equal to the first term times the common ratio raised to the n minus 1 power. So a sub n, the nth term, is 4,096th. And the first term is 1, and r is... we didn't find r yet, right? R is the ratio of terms, and the ratio of the second term divided by the first term is a half. The ratio of the third term divided by the second term is also a half. A quarter divided by 1/2 is also a half. So our common ratio is 1/2. And so no need to divide by 1. We're just going to solve for the exponent. N minus 1 is equal to the log base 1/2 of 1 divided by 4,096, and our calculator ready form is 1 plus the log base 1/2 of 1 divided by 4,096, and that will give us a result of 13. So n is equal to 13. There are 13 terms in the sequence, or 1 divided by 4,096 is the 13th term of that sequence.